Look up tonight. Find a star. Any star will do. Now ask yourself, is it still there? Not there in the sky, where you see it. There, actually existing, burning, fusing hydrogen into helium in some distant corner of space. Because here's the uncomfortable truth nobody mentions when they're teaching you about constellations. Some of those points of light are ghosts. Echoes. Photons that left their source thousands of years ago, traveling through the void, only to arrive here, now, in your eye, carrying the image of something that no longer exists. You're not looking at the universe as it is. You're looking at the universe as it was. 1,000 years ago. 10,000. 1,000,000. And somewhere out there, right now, stars are dying. Exploding. Collapsing. And you won't know for centuries. Maybe longer. The light keeps coming. Long after the star is gone. We call it ghost light. And once you understand it, really understand it, you can't unsee it. Every star becomes a question mark. Every constellation becomes a cemetery of maybes. It changes how you look at everything. I want to tell you about a photograph. It was taken by the Hubble Space Telescope in 2018, though the data had been sitting in archives for years before anyone realized what they were seeing. The image shows galaxy clusters, massive collections of galaxies bound together by gravity, glowing bright against the cosmic background. But between the galaxies, in the spaces that should have been empty, there was light. Faint. Diffuse. Ghostly. They called it intracluster light. Light that doesn't belong to any galaxy. Light from stars that have been ripped from their home galaxies by tidal forces, now drifting alone in intergalactic space, shining dimly in the void. Orphan stars. Dead galaxies. Ghost light. And here's what got me. This light had been traveling for billions of years. The stars that produced it, most of them are gone now. Burned out. Collapsed into white dwarfs or neutron stars or black holes. But their light is still here. Still traveling. Still visible. We're seeing the afterimage of destruction. The residue of violence that happened so long ago that entire civilizations could have risen and fallen in the time it took that light to reach us. And we look at it and we call it beautiful. There's something deeply human about that. About finding beauty in remnants. In things that no longer exist but whose effects linger. Isn't that what memory is? Isn't that what grief is? The ghost light of people and moments that are gone, but whose photons, whose impact, are still arriving, still shaping how we see the world. The universe runs on lag time. Always has. And understanding that lag, understanding the gap between what happened and what we perceive, that's where things get strange. Light travels at 186,000 miles per second. That sounds fast. It is fast. Nothing in the universe moves faster. But space is so incomprehensibly large that even at that speed, light becomes a time traveler. The sun is 93 million miles away. Its light takes 8 minutes and 20 seconds to reach Earth. Which means when you look at the sun, don't actually do this, you'll damage your eyes. You're not seeing the sun as it is now. You're seeing it as it was 8 minutes ago. If the sun suddenly vanished, blinked out of existence like a candle in the wind, we wouldn't know for 8 minutes. For 8 minutes, we'd still see it. Still feel its warmth. Still live in a solar system that, technically, no longer had a sun. And then, all at once, darkness. That's the nearest star. Now scale that up. Proxima Centauri, the closest star to our solar system, is 4.2 light-years away. When you see it, and you can, if you know where to look, though it's faint, you're seeing light that left that star over 4 years ago. If someone on a planet orbiting Proxima Centauri looked at our sun right now, they'd be seeing Earth as it was in 2021. Different president. Different problems. Different version of you. Sirius, the brightest star in our night sky, is 8.6 light-years away. The light you see tonight left Sirius in 2016. Betelgeuse, that red supergiant in Orion's shoulder, is 550 light-years away. When you look at Betelgeuse, you're seeing the Renaissance. You're seeing light that left that star around the time Copernicus was telling everyone the Earth orbits the Sun, not the other way around. And Betelgeuse is close. Practically in our backyard, cosmically speaking. The Andromeda Galaxy, the nearest major galaxy to our Milky Way, is 2.5 million light-years away. The light you see from Andromeda left that galaxy before humans existed. Before Homo sapiens. Before our ancestors even walked upright. So when you look at Andromeda, you're not just looking across space. You're looking across time. You're seeing the past. You're seeing a version of that galaxy that no longer exists. Stars have been born and died in the time it took that light to reach you. Entire stellar generations have come and gone. And you're just now finding out. This is what astronomers deal with every single day. The light speed limit isn't just a constraint on travel. It's a constraint on knowledge. On certainty. On ever really knowing what's happening out there, right now, in real time. We don't get to see the universe as it is. We only get to see the universe as it was. And the farther we look, the farther back in time we're seeing. The most distant galaxies ever observed are over 13 billion light-years away. We're seeing them as they were 13 billion years ago, less than 1 billion years after the Big Bang. Those galaxies don't look like that anymore. They've evolved. Merged with other galaxies. Maybe collapsed entirely. We have no idea. We won't know for another 13 billion years. We're ghosts to them. If anyone out there is looking back at us, they're not seeing Earth. They're not seeing the Sun. They're seeing the cloud of gas and dust that would eventually become our solar system. They're seeing the raw materials. The ingredients. Not the meal. Time and distance have made us all into archaeologists. Every observation is an excavation. Every photon a fossil. But here's the question that keeps me up at night. How many of the stars we see are already dead? It's a simple question. It should have a simple answer. But it doesn't. Because the answer depends on how far away the star is, how long it lives, and when it dies. And we don't always know those things with precision. Most stars live a long time. A very long time. Our Sun is about 4.5 billion years old and has another 5 billion years to go. Red dwarfs, the most common type of star in the universe, can live for trillions of years. Trillions. The universe isn't even old enough for a single red dwarf to have died of old age yet. So statistically, most of the stars you see in the night sky are still alive. Still burning. Still there. But not all of them. Massive stars, stars 10, 20, 50 times the mass of the Sun, they burn hot and fast. They live for only a few million years before running out of fuel and exploding in supernovae. And when they explode, the light from that explosion travels outward at the speed of light. But it still takes time to reach us. Betelgeuse, for instance. That red supergiant I mentioned earlier. 550 light-years away. Astronomers think it's near the end of its life. It could explode tomorrow. It could have already exploded 500 years ago, and we just don't know yet. The light from the explosion is still on its way. Every night, when you look at Betelgeuse, you're looking at a star that might already be gone. You're looking at a ghost that hasn't realized it's dead yet. And you won't know. Not until the light arrives. Not until one night, you look up, and there's a new star in the sky, bright enough to see during the day, bright enough to cast shadows at night, and you'll realize that's not a new star. That's the death of an old one. That's the supernova. That's the ghost light arriving. But by then, the explosion will have been over for 550 years. You're just getting the news late. This happens more often than you'd think. In 1987, astronomers observed a supernova in the Large Magellanic Cloud, a small galaxy near the Milky Way. They called it SN 1987A. It was the closest supernova visible to the naked eye in nearly 400 years. But it didn't happen in 1987. It happened 168,000 years ago. That's how far away the Large Magellanic Cloud is. 168,000 light-years. The star exploded when Homo sapiens was just beginning to spread out of Africa. The light traveled for 168,000 years, across the void, and arrived just in time for modern humans with telescopes to observe it. We saw the death of a star that died before civilization existed. Before agriculture. Before writing. Before we even knew what stars were. The ghost light doesn't care about our timelines. It arrives when it arrives. And that's just supernovae. That's just the dramatic deaths. What about the quiet ones? Most stars don't explode. Most stars just fade. They burn through their fuel, puff off their outer layers, and leave behind a dense core, a white dwarf or a neutron star, cooling slowly over billions of years. And sometimes, by the time their light reaches us, they're already in that fading phase. Already cooling. Already transitioning from star to remnant. We're seeing their glory days. Their youth. Their prime. But out there, in real time, they're old. Tired. Dying. The Hubble image I mentioned earlier, the one with the ghost light between galaxies, it showed exactly this. Light from stars that had been torn from their galaxies millions, maybe billions of years ago. Stars that are almost certainly dead now. Or at least, in their final stages. But the light keeps coming. The photons keep traveling. And we keep seeing them. Astronomers estimate that in a typical galaxy cluster, about 10 to 50% of the total starlight comes from these orphan stars. Stars that no longer belong anywhere. Stars drifting in the vast spaces between galaxies, slowly fading, slowly dying, but still visible from across the universe. Ghost light. Everywhere. More common than you'd think. And it makes you wonder, what else are we seeing that's already gone? What other cosmic events are we witnessing on delay, not realizing we're watching replays of a universe that's already moved on? The answer is, almost everything. Every galaxy. Every nebula. Every quasar. Every burst of gamma rays. All of it is old news by the time it reaches us. Some of it is ancient news. The most distant object ever observed by the James Webb Space Telescope is a galaxy called JADE's GSZ 13-0. It's 13.5 billion light-years away. We're seeing it as it was just 300 million years after the Big Bang. That galaxy doesn't exist anymore. Not in that form. It's had 13.5 billion years to evolve. To merge with other galaxies. To form new stars. To maybe even host planets. Maybe even life. But we'll never see any of that. We're stuck watching the prologue. The opening scene. The universe's baby pictures. And we call it cutting-edge astronomy. It's humbling, when you sit with it. All our telescopes, all our technology, all our brilliant minds working to understand the cosmos, and we're fundamentally limited by the speed of information. We can't know what's happening now. We can only know what happened then. And then gets farther away the farther we look. But there's a flip side to this that nobody talks about. A strange comfort hidden in the light speed delay. If we're seeing the past when we look at distant stars, then distant stars are seeing our past when they look at us. If there's anyone out there looking, and that means somewhere in the universe, right now, there are photons carrying images of Earth from centuries ago, from millennia ago, from before humans existed. Light doesn't just show us the past. It preserves it. Every moment that's ever been illuminated by light is still out there, traveling through space, carrying that moment forward like a message in a bottle that never stops drifting. The Earth as it looked during the American Revolution is still visible. Those photons are 248 light-years away now, forming a sphere of light expanding outward at 186,000 miles per second. Any civilization with a powerful enough telescope at exactly that distance could watch the signing of the Declaration of Independence. Not as history, as live footage. Delayed footage, sure, but to them, it's happening now. The Earth during the Renaissance? 450 light-years out. The fall of Rome? 1,700 light-years. The construction of the pyramids? 4,600 light-years away, still traveling, still carrying that image of ancient Egypt outward into the galaxy. And before that? Before civilization? The light from Earth when it was just dinosaurs and ferns and endless ocean. That's 65 million light-years out now, propagating through space, an eternal broadcast of a world that no longer exists. Every version of Earth that's ever been illuminated by the sun is still out there. Still visible. Still real, in a way. Frozen in light. Traveling forever. We think of the past as gone. As finished. But light doesn't work that way. Light makes the past portable. Transferable. Eternal. And if that's true for Earth, it's true for everything. Every star that's ever shone. Every galaxy that's ever glowed. Every supernova that's ever exploded. The light from all of it is still out there, somewhere, carrying those events forward through time and space. The universe doesn't forget. It can't. The light won't let it. There's a thought experiment I've been turning over in my mind lately. It's about perspective. About what it means to see something that's already over. Imagine you're standing on a beach at sunset. The sun dips below the horizon. It's beautiful. It's peaceful. It's one of those moments that feels timeless. But the sun you're watching set? It already set 8 minutes ago. You're watching a replay. The actual sun, the real sun, is already below the horizon. Has been for 8 minutes. You're just now getting the memo. Does that make the sunset less real? Less beautiful? Less meaningful? No. Of course not. The experience is still real. The light hitting your eyes is real. The emotions you feel are real. The moment exists, even if it's technically in the past. Now scale that up. The star you're wishing on might have exploded 1,000 years ago. Does that make your wish less valid? The constellation you're using to navigate might not exist anymore in that configuration. Does that make the navigation less effective? The ghost light still works. Still guides. Still illuminates. Even when the source is gone. And maybe that's the point. Maybe the lesson hidden in the light speed delay is this: the past isn't really past. Not completely. Not as long as its effects are still reaching us. Not as long as the light is still arriving. Your childhood is over. But the person you became because of it is still here. Your grandmother is gone. But the lessons she taught you still guide your decisions. That relationship that ended 5 years ago, it's over, yes, but the way it changed you is still present. Still shaping how you love. How you trust. How you protect yourself. Ghost light. All of it. photons from dead stars, still arriving, still affecting the present. We're all made of ghost light, in a way. Made of influences and echoes and aftereffects from things that are technically over but whose impact continues. The universe figured this out long before we did. Long before we were even here to think about it. There's a phenomenon astronomers call light echoes. It happens when a sudden bright event, like a supernova, illuminates dust clouds around it. The light from the explosion travels outward in all directions. Some of it reaches us directly, but some of it bounces off dust clouds at various distances and angles before reaching us. So we see the supernova once. The direct light. And then, months or years later, we see it again. Reflected. Echoed. The same event, arriving twice, because the reflected light took a longer path to get here. It's like hearing someone shout in a canyon and then hearing the echo a moment later. Same shout. Different arrival time. The canyon doesn't create new sound. It just delays the original. Light echoes let astronomers study supernovae that happened decades or even centuries ago. Not through records or photographs, through actual light from the event itself, still bouncing around, still finding its way to us. In the early 2000s, astronomers observed light echoes from a supernova called Cassiopeia A. The supernova happened around 1680, over 300 years earlier. But the light had bounced off distant dust clouds, taking a longer route, and was only just arriving at Earth in the 2000s. They were able to analyze that 300-year-old light with modern instruments. They could study the chemistry of the explosion, the velocity of the debris, the type of star that died. All from light that had been traveling through space for 3 centuries, waiting for the right instruments to exist to capture it. The past reached forward. The ghost light arrived right on time. Just 300 years late. And here's the really strange part. This means the universe is filled with delayed information. Echoes and reflections and photons bouncing around, taking scenic routes, arriving out of order. Somewhere in space, there's light from the Big Bang that's still traveling. Still bouncing off things. Still finding new paths. The cosmic microwave background radiation, the afterglow of the Big Bang, it's everywhere. We can detect it from any direction we look. But that's just the light that took the most direct route to us. There's other light. Light that took longer paths. Light that got delayed. And it's still out there. Still coming. The universe is haunted by its own history. Every event that ever produced light has left a trail. A residue. A ghost. And we're living in that haunted house. Surrounded by light from things that are over. From stars that are dead. From galaxies that have moved on. From moments that ended billions of years ago but whose photons are still arriving, still visible, still shaping what we see when we look up. Carl Sagan used to say we're made of star stuff. And he was right. The atoms in our bodies were forged in the cores of dying stars billions of years ago. We're literally made of ancient stellar material. But we're also surrounded by star stuff. Not just atoms. Light. Information. Images. Echoes. Every breath you take happens in a universe illuminated by ghost light. Every moment of your life is witnessed by photons that left their sources before you were born. Before your parents were born. Before your species existed. And one day, assuming we don't destroy ourselves first, our descendants will look out at the universe and see our sun as ghost light. They'll be so far in the future that the sun will have died. Swelled into a red giant. Shed its outer layers. Collapsed into a white dwarf. Cooled to darkness. But the light from our sun's bright years will still be out there. Still traveling. And if someone happens to be in the right place at the right time, they'll see it. They'll see the sun as it was when we were alive. When Earth was habitable. When there was life here. They'll see the ghost light of a system that used to matter. That used to be home to a civilization that built telescopes and wondered about the universe. And they won't know we're gone. Not from that light. The light will show them a thriving star. A living world. The ghost light will lie. Not maliciously. Just inevitably. Because that's what ghost light does. It preserves the past. It presents it as present. It makes what's over look like it's still happening. And maybe that's okay. Maybe there's something poetic about the idea that even after we're gone, long after, the light from our world will still be traveling. Still visible. Still telling the story of a planet that was, for a brief moment in cosmic time, alive. We'll become someone else's stars. Someone else's ancient history. Someone else's ghost light. The cycle continues. Always has. Always will. Because light doesn't stop. It can't. It just keeps going. Carrying the past forward. Making history visible. Turning endings into eternal broadcasts. And somewhere out there, right now, there's light from a star that died before Earth formed. Before the sun ignited. Before our galaxy even looked the way it does now. That light has been traveling for billions of years. Through voids and clusters. Past dead galaxies and newborn nebulae. Across distances so vast they break human comprehension. And tonight, if you're in the right place with the right equipment, that light might arrive. Might hit a telescope mirror. Might get captured by a sensor. Might become data. And for just a moment, something that ended billions of years ago will be present again. Visible again. Real again. That's the promise of ghost light. That's the gift and the curse of living in a light-speed universe. Nothing is ever truly gone. Not as long as its light is still traveling. And everything, absolutely everything, is still traveling.